Hello, everyone, and happy Star Wars Day. May the 4th be with you. Thank you for joining me. My name is Zach. This is Hudson Public Library's Science Explosion, and I am glad to have you all here. So, let's get started. So I've got a few different little things to show you today, a few demonstrations, and a craft to make, all on the theme of Star Wars. So first up, I want to talk a little bit about the Force. So I've got just a simple paperclip here, and using the Force, I will make it fly into my other hand. Do you believe me? Well, we'll see. You probably don't, but that's okay. So magic. Can I get it to go? Maybe. There we go. I'll do it again. See, it flew up. All right, so I'm guessing most of you know what I'm doing here. So I've got a magnet taped to the bottom of my hand, and I'm just getting it to go to that magnet. So I think this trick also works really well if you've got something like a book, and you can see I'm moving it around like that. There we go. I think that shows up a little bit better on the film. So just magically. So I know you all know that's not magic. That's science, just like Bill Nye always says. But I think that it's fun to talk about this because I'm using not the force, but I'm using a force. So I'm using electromagnetism. So if you've never heard that word before, think about the two different words you hear in it: electro, so electricity, and magnetism, like magnets. So electromagnetism. So those are really one force, and they're one of the four fundamental forces in our universe. Now, I will be very impressed if anybody can tell me what the other three are. So we used to think that electricity and magnetism were different, but we know that they're pretty much connected as the same thing. And you can prove that to yourself too by making an electromagnet. So you can use electricity to create a magnet, but you can also use magnets to generate electricity. That's what a lot of generators work as. All right, so do you know what the other forces are? All right, so they are electromagnetism, the strong force, the weak force. So they're also called the strong and weak nuclear forces. And then you've also got, by far, the weakest of these forces. Do you know what the last one is? It is gravity. Gravity, it might surprise you to know, is way, way weaker. But think about this. You see this paperclip here. What will happen if I drop it? The answer is pretty obvious. It'll fall. All right. And I've got this magnet right here. And what'll happen? So holding this here, if I were to move my hand, this paperclip would fall, right? So there's that force of gravity pulling it down. But this magnet will easily overcome the force of gravity and pull it upwards. Why? So I want you to think about this. What is pulling this down? Well, that is being pulled down by gravity of the entire planet. It's not just this counter, it's everything. So everything with mass has gravity. And the bigger it is, the more mass it has, the more of a pull of gravity it has. And that's how weak gravity is. The gravity of this entire planet is weaker than this magnet, this tiny magnet. Gravity is so weak, but it has a huge effect because things are so big. So I want you to join me for the next little demonstration that has to do with gravity. All right. So what do you think the force is? What kind of force is it? So I want you to think about that. I will say I've seen a great video on this all about what the force could be. And as long as you're all right with the prequels and talking about midichlorians, which are canon now, so I know some people aren't happy with that, but they are, then a lot of this person was actually comparing them to mitochondria. So anyway, I'm going to get to the gravity demonstration here. All right, so if you want to do it yourself, it's pretty easy. All you need to do is I've got just a little cookie container here that I put a t-shirt over and then rubber banded it here and here so I can hold it pretty easily. And I'm going to show you a little bit about gravity. So this might not make any sense right now, but don't worry, it will, hopefully. So gravity, we know, is a force, and it's going to pull whatever I drop down. Now, I know there's some smart people who watch these. I think you're all smart people, but I know there's somebody who's watching this that might be thinking, well, Zach, not everything that you drop is going to fall. And that is a really, really good point. So if I were holding a helium balloon, it's going to rise, not fall. Now, here's the thing. If I was in space, or if there was no atmosphere here, then it would fall. The big difference is that helium is less dense, so it's lighter than air. So it's going to rise while the air is sinking. Remember that air has mass too. All right, but anyway, here is the gravity. I always love going on tangents. Anybody who watches these has probably figured that out by now. All right, so you need to get one of these. Now, the bigger you can make this, the better. I'm doing it in this small one so that I can not have to get way wider on the camera angle to show you this. But if you can do this with a hula hoop and a larger piece of fabric, you're going to see this way, way better. So the larger you can do this, the easier it'll be to see. All right, then you need a couple objects. I've got a ping pong ball, a golf ball, and then I've got some marbles. All right, so if you put the ping pong ball on here, what happens? What do you notice? Well, it's pretty light, but it kind of pushes it down a little bit. Well, what about a golf ball? Okay, well, that's different. So now you can see, hopefully at this angle, yeah, there we go, that golf ball has created a curve in here. All right, so now I'm going to take a marble and I'm going to show you what happens if I try to roll a marble straight forward at basically 90 degrees to this golf ball. What's going to happen? What do you think? Well, let's see. I'll try to hold this steady. So whoop, it didn't go in a straight line. Did you see that? So it might be kind of hard to see. There we go. So you can actually see it didn't just not go in a straight line. When I tried to roll it forward this way, it rotated around this golf ball. Now, what does that remind you of? Alrighty. So what would happen if I used a differently sized marble? This is a much larger marble, and do the same thing. So that rotated it all the way around this, but it fell into it much quicker. All right. So does anybody realize what I'm showing you with this demonstration? Well, this is a demonstration of how gravity works. So normally we think about gravity as just pulling things towards, whoops, drop that. I'm gonna leave that in the video. So we think about gravity as pulling things towards that. But according to Einstein, gravity is a little stranger than that. And that is because gravity actually isn't just a force, it's a warping of space, and not just space, space-time. So remember, space and time are connected. Think of time as being like the fourth dimension. So you've got one dimension, 2 dimensions, 3 dimensions, and then fourth is time. So right now, the larger an object is in space, the more it warps gravity. So I asked you what this reminded you of when I try to put this forward and it ends up rotating around that, the one that is pulling it down in the center here. And I think you might have noticed it's very similar to a planet's rotation around the sun, or a satellite like the moon's rotation around the Earth, or any moon around another planet. So there's a big reason for that, and that's because this is actually a pretty good way to visualize how gravity works. Gravity is, think about the flat surface of this as being space, and then you've got something with mass, say a planet, and it's warping that space. And it's making things fall into its orbit if they go into that. So that's why if something goes towards Earth, like an artificial satellite, it can become a part of our orbit. So what does this have to do with Star Wars? Oh, well, it has to do a lot with Star Wars, because this is a gravity well, is what I'm leading up to here. So think about the fact that the larger your mass is, the more it warps space. So the sun warps space a lot more than the Earth warps space a lot more than the moon, and the moon warps space a lot more than you. But there are things way more massive than the sun, way more massive than the sun. So our sun isn't even a large star. So black holes. Black holes are incredibly dense. Think about them as if you were to try to condense this entire building into the size of this ping pong ball. It wouldn't even come close to as dense as a black hole is. So black holes are so massive, they warp space-time so much, their pull of gravity is so big that not even light can escape from them. So that's big. So you see these types of things in Star Wars all the time. And if you've heard Han Solo talk about his famous Kessel Run, then that actually has a lot to do with why he's talking about how many parsecs, which is a unit of distance, not time, he was able to complete it in. I love the original interpretation of that, though. So when I was told that that a parsec was a unit of distance, not time, my assumption was Han Solo was just trying to trick Obi-Wan and Luke and trying to see if they knew anything about space travel. But anyway, that's not the canon anymore. So I think this is a really good way to visualize this, of how large objects can affect what space-time is. So think back to that ping pong ball. It's got the same size, just a little bit smaller than the golf ball, but so much less mass, so it's not warping it as well. And you can think too about how there's different densities of things in space. So if you are a space traveler like you find in Star Wars, you will need to know that when you are plotting your courses, because if you don't take into account how gravity affects space-time, you will actually not travel the right distance. So when you see anyone on Star Wars plotting their light speed course, that's part of what they're doing. They, I'm sure, have complicated algorithms in their computers that figure this out for them when they plot their courses. But basically, they need to know that if they were to ignore where a planet is and its pull of gravity, they would wind up in the wrong spot. Now, this is all well and good, you might be saying, Zach, but is there any way to see this actually happening? And yes, there is. So if you look up gravitational lensing, this is a good way to demonstrate this. And this is what happens when the image that we see from space is different than what it would be if there wasn't the warping of gravity. So you can actually, I'll just let you look that up yourself. There's some cool things that you can see with this. Alrighty, so that is another one that we've got here. All right, so next up, I'm going to talk about space travel in general because there is one big problem with wanting to space travel like we have now. All right, and it's not just that we can't travel faster than the speed of light, but there's one problem that even a lot of sci-fi movies don't talk about. So you may have seen the famous wormhole argument. It's a pretty simple one. So if you want to travel from here to here, what's the fastest way to get there? Well, most people would say a straight line. But always remember, think in higher dimensions. So the fastest way to get from here to here is to connect those 2 points. So that's a wormhole. And that would solve a lot of your problems with having to travel to distances. And I have good news for you. Wormholes are, at least theoretically, possible. So a lot of astrophysicists say that it is possible to have a wormhole, and even better, it's possible to make a wormhole. Now, it's very difficult. We don't have the abilities to do it right now, but someday we might. And I just want to tell you, I don't think a lot of people have realized the most exciting thing about, well, one of the most exciting things about if we are able to travel somewhere faster than light gets there. So if we could somehow travel faster than the speed of light, which probably can't happen because laws of physics, but maybe, or if we could do a wormhole and travel there before our light gets there. So remember, light has a speed, it's very fast, but it definitely has a speed. So if I could get somewhere 4 light years away instantly, what will they see if they look at Earth? Well, they're going to see Earth from 4 years ago. So if I can get to somewhere 4 light years away and then look at it with a telescope from I would see Earth from 4 years ago. You have a good enough telescope, you can even see things like weather patterns. You had a really good telescope, you might even be able to see some things that civilizations are building, some patterns. So I think it's pretty neat. All right, so this next demonstration, all you need is a balloon and a marker. So space travel, it's pretty exciting, but there's one thing that's really important to know about space. So I'm going to draw a few stars, or not stars, we'll say these are galaxies. Look at that. I just made each of these dots, let's say, is a galaxy. Let's say that one's us right there, and we want to travel to that one right there. Simple enough. The distance we need to travel is from there to there. Let's pretend there are no wormholes or anything like that. So if we have light speed, it might take us a few, I don't know how long, a while. And if we don't have light years, it's going to take us a lot longer. But there's one extra challenge, and that is the reason that I did this on a balloon in the first place. Space isn't just staying there. Space is changing. So we're right there. I'll pick one that you can see a little better because that one I did a little too light. We're right there. We want to go there. It's farther away now. Still farther. There to there. There to there. There to there. It keeps getting farther and farther away. Because I don't need to tie it. So this is actually what's happening right now. Space isn't just static, it's expanding. So think about it as like these dots on the balloon. So we've got some galaxies that are pretty close to us. If we were to take off in a generational ship, so that's a ship that multiple generations live on, and eventually somebody would get on them, you'd think that we could make it to that other galaxy, right? Eventually. Not necessarily, because it's not just that it's moving away from us, because galaxies do move, But the big problem is space is actually getting bigger. So the distance between us and that galaxy is actually expanding faster than we are able to travel. So think about it like if you were walking down the sidewalk from one building to the next, and they keep laying more sidewalk tiles between you and you get pushed back. Well, if you're walking one tile a second, but they're putting 2 tiles every second on there, you're never, ever going to make it over there, no matter how long you walk. That's the big problem with space travel. So that's making it to another galaxy, though. So there is going to be some expansion within a galaxy as well. And so it's still going to be a problem for us getting to a closer star, but it's not nearly as far. So in Star Wars, they've clearly got faster than light speed travel, and they are able to get around it. So, alrighty. Let's talk about space, because one thing I think a lot of people point out when you're talking about the science of Star Wars is space. Now, there's a lot of sounds in Star Wars in space. What does space sound like in our galaxy? You know? Well, a whole lot of nothing. So we can hear things on Earth because there's an atmosphere here, but sound needs a medium to travel through. So in the emptiness of space, nothing, there's just no sound. Now, I love Star Wars and I love those movies, and those space scenes, the dogfights, they wouldn't be, so if you've never heard that term, I should explain it. So a dogfight is what they use to describe when 2 planes are fighting, or also when 2 spaceships are fighting. It has nothing to do with dogs fighting. But when the ships are fighting in space, it wouldn't be quite as fun to watch if there wasn't those sounds. Alrighty, so we got that there. I need to grab another drink of water. Alrighty, so when I think of Star Wars, there are so many things that come to mind, but when I think of the cool technology they have, obviously I'd love to have the ships, I'd love to have the droids, things like that, but I think something that we on Earth have dreamed about making for a long time and is really cool is a hologram. So I'm going to show you how to make one. We're going to make one today, and it's going to cost you maybe pennies to make. Pretty exciting? Yeah, I think so. So it's not going to be quite like those holograms you see on Star Wars, but it's going to be something I think pretty cool. So all you need is a few simple things. So there's a template of a rhombus on the link in the description, or on the description. There is a link in the description. It looks like this. So what you do, print this out and then cut that out. So you'll get one that looks like this. Then you'll take, I've got right here some overhead projector paper. It's just clear plastic. Now, if you don't have this, then laminate paper would also work. Or if you happen to have some old CD cases, those are actually going to be the best thing that you can do because they will be a lot sturdier. All right, so then you're gonna put this on here and then trace it 4 times and then cut all of those out. And then you're going to tape it so that all 4 sides stick together. Now I'm going to take one I already made apart just a little bit to show you. There we go. So then you lay it out. Here's one, tape to this side, tape the flat sides together so that the smaller side is facing inward, tape there. And then obviously if this is laid flat, then you wouldn't be able to tape this last side. So you need to bring it up so that it can be taped on there as well. You'll want to get your marker off of the edges a lot better than I did. And then this will be able to sit just like that. Now, the other link that I've got in the description is for some videos. So you will need a specific kind of video to make this projection with. All right. And you will also need a smartphone. So if you don't happen to have a smartphone, then you can try to use something like a tablet. You might be able to get this to work on a computer if you lay it right. You might just need to change up the sizes of these things, but I'm going to do it on here. So there are different videos that are linked in this that will work. All right, so I'm going to go turn off the lights to show you what this looks like, because you won't be able to see it very well with as bright as it is. Okay, let's hope that this can show up in this amount of light. We'll see. So the darker this is, the better it'll show up. So remember, this is what it should look like. So basically a pyramid with the top cut off is what this is. Let's see, we'll lay flat. Good. So I have already got it loaded on here. The video I picked is Blooming Flowers. I don't know why it makes that noise in the beginning. Let's see if I can get this set up to work. Kind of. I can see that you can kind of see it on there. Right there. Let's see. A little bit. I'm going to close the curtains here and bring it up so that you can see it just a little bit better here. Okay, I got the curtains closed. Let's see if this will show up just a little bit better. You can kind of see it. So I will say it's not going to show up very well on here, but it will show up quite well in person. That's a dark flower. Okay. But the neat thing about this is viewing it from any angle 360, you will still be able to see it. Let's see. Oh, there's a white flower. That will show up a little bit better here. So, yep, you can see it right there. And even when I rotate this, you can still see it. It keeps changing to different views. So this is what it actually looks like on my screen of the phone, is there, and then that's where you put this. So you'll put it like this with the flat side, just like that, making a square. So look at that. That is a real life hologram. So I think that is so much fun. So I hope that you try that one out. So I've got a CD case here to show you. You would just need to cut out like along here. You'll need to use some very sharp scissors to do that. So if you need some parental help, that is fine. Also, the nice thing about this is I figured out, well, somebody helped me figure out when they pointed it out to me, you can fold this up and take it with you too. So, alrighty, that is all the Star Wars science I have for you today. If you want another challenge, then my challenge for you is build your own droid. Let's see what you can come up with. There are lots of different types in Star Wars, so I think you can make your own and make it creative. So thank you everyone so much for joining me. My name is Zach. This is Science Explosion at Hudson Public Library. Have a nice one. May the 4th be with you. Bye.